Suppose your LLM responses are slow, P99 latency is bad, but your GPU utilization still looks fine. Usually, we start looking at the model or think about adding more GPU capacity. But before doing that, we need to understand what happens after an LLM request enters the LLM serving system, because it behaves very differently than a normal backend request. In a normal backend system, a request comes in, some processing happens, and eventually it completes. The cost can vary, but usually we have a reasonable idea of how much work it will do and how long it may take. An LLM request stays active for much longer because the response is generated one token at a time. After the prompt is processed, the model generates the first token, then the next one, and it keeps going until it decides to stop. One response may finish after 20 token, and one response may continue till 500 token, and another may continue for 2000 tokens. The serving system does not know the final output length when the request arrives. Two requests may look similar at the beginning, but once generation starts, they can occupy the GPU for completely different amount of time. One finishes quickly while the other keeps returning for its next token. That becomes important when these requests are batched together. GPUs are built for throughput, so processing several requests together is more efficient than running them one by one. The simple approach is to collect a few requests from a batch and run the batch until all the requests are complete. Here we have 4 requests starting together. Their output lengths are different. One is 300 token, second one is 2000 token, then 150 and 500 tokens, which is normal in LLM serving system. Some requests generate short answers and finish early, while one request continues for much longer token generations. Once these shorter requests finish, their position in the batch are no longer producing tokens. The batch is still running because the longest token generating request has not completed yet. So new request cannot come immediately to use this capacity. This is why GPU can look busy while the serving system is still inefficient. The model is running and one sequence is generating tokens, but part of the batch is already empty. Here, the long running sequence controls the lifetime of the batch. We still need batching because without it, GPU throughput will be poor. The issue is keeping the original batch fixed until the longest sequence finishes. An LLM request keeps generating for an unknown duration, so the serving engine needs to reuse a slot as soon as a sequence is done. Continuous batching allows dynamically adding and removing of the request from the running batch while generation is still in progress. Instead of treating the batch as a fixed group of requests, the scheduler look at the sequences that are currently active and need their next token. The model runs one generation step, and every active sequence in the batch gets one more token. After that step, the scheduler checks the sequence again. If one has finished, it leaves. If another request is waiting and there is enough capacity, it enters. So the batch changes over time. It is no longer created once and kept unchanged until everyone finishes. A short request can complete and free its position, while a longer request continue generating their next token. That freed space capacity can be used by another request on the next scheduling iteration. The useful way to think about this is that the scheduler is working with active sequences, not only with the requests that arrive together. Every sequence needs one more token. The scheduler decides which sequence participates in the next model step, removes the ones that are complete, and admits new work when a space becomes available. This is why continuous batching is such an important part of modern inference engines. It improves the turnover of the batch without requiring a different model or a different GPU. This also explains why request count and GPU utilization can be misleading. 100 short generations and 100 long generations are not the same workload, even though the request count is identical. So when P99 gets worse, batch behavior and output length matters just as much as how busy the GPU looks. Continuous batching keeps more sequences active, but every active sequence also holds KV cache on the GPU. See you in the next one.